for the next 20 years that the owner can get its economical value. So we considered the forward citation for the next 20 years. After we got this, we constructed some citation graphs, say a graph GVE, where V is the set of the vertices in the graph constructed by the patents, and then the forward citation patents, and then the set of edges E. And any edge from a vertex VI to VJ means that VI is citing VJ. These edges are then used as input to Closet-Newman-Moore's community structure algorithm. In case you have any question about community structure, I can answer that later on. But let me just tell that community structure are a group of vertices in a network or group such that they have very dense edges with the vertices in that group, but not so dense edges with the vertices of some other network. So I'll have very dense edges with my friends in my group, but not very dense edges with other people in some other groups. That's the idea behind community structure. This is the thing that we got. These are the windows, 80 to 81, 85 to 90, so each consisting of 5 years. The number of community structures that you get for each window. This column will give you the number of patents in the top largest community. This is the number of patents in the second largest community in the green energy sector. This is the number of the patents in the third largest community. And those are the number of patents in the smallest community, and so on. So we are going to proceed with this part, which is basically the top largest, second top largest, and third top largest communities within the US green energy sector. So we are going to proceed with this. We take them, we make them as inputs to a Java program again, and then we find the main patent classes under which each patent was filed. So this basically gives us the constituent patent classes for the top 3 communities in the green energy sector. If we go to the top largest community for all the 5 windows, we see these are the community names for those communities which have been as the top largest in all the 5 windows. Those are the patent classes. Now here, if you check, you'll see that this top largest community is mainly dominated by dynamo plants, motors, etc. Sometimes wind, sometimes wave and tidal, turbo generators, and so on. In the second largest community, in the top 5 windows, you again see the dynamo plants coming out. Now you can question me why dynamo plant is in both the first and the second. Here, if you see, the dynamo plants is wave and tidal in the first window. If you refer to the top largest, you'll see that that was wind. So basically, wind and wave or tidal, so if I categorize them as wind and hydro, they come out as the first and the second every time. In all the windows, they come out either as the first or the second. So they have been having an absolute dominance. The third largest community is composed of a combination of solar heat collector, maybe solar cookers or something, refrigeration, turbo generator, and interesting fuel cell coming up. So that's a new thing that's kicking up. This is the individual contribution by each energy sector. The first 3 bars are for the first largest, second largest, and third largest community in window 1. Again, these 3 as the first, second, and third largest in window 2, and then we have it for all the windows. As you see here, water and wind, emperors, absolute dominance over all the sectors. Bio, geothermal, they are coming up, but then they have an absolute dominance, and the individual shares you can see over there. So based on this, we designed our V&D model, which is basically modeling of the renewable energy technologies, and we categorize them into 3 categories. There's the veteran community, newbie, and the downgraded community. The V of our V&D model stands for the veteran community, which means those classes which have been in prominence from the early 1980s till today. And they have had an absolute dominance over all the other sectors. Prime mover dynamo plants, motors, fluid reaction surfaces, power plants. The N, the newbie, those which are kicking up right now. Fuel cell, single generator system. They seem to be very promising for the coming days, but we do need more research to substantiate that, whether they are going to be the leaders or not. The D is for the downgraded community, which were once popular but now disappearing. Solar heat collector, hydraulic earth engineering, refrigeration using solar energy. Possibly because they have been replaced by newly evolving technologies in the green energy sector, maybe due to fuel cell, maybe due to generators coming up, but they have lost their importance and they never come up as the first or the second communities. Now we will come to the green technology tree, which is basically a tree structure based on our analysis. This is a tree growing from the left to the right, shown by this arrow, divided into 5 sections for the 5 windows. This is the main stem of the tree, which constitutes the top largest community for all the 5 windows. If you see here, you'll see that dynamo plants, which is class number 280, has an absolute dominance over all the 5 windows. Though sometimes it shares its place with some of the other technologies, but we basically say that dynamo plants has been playing a great role in the US green energy sector. So that constitutes the stem of my tree. Then we have some large secondary branches which come out from the stem of the tree, and these are the sectors which had been occupying the second rank in the green energy sector. So I have made them bend towards the right, meaning that they are also evolving and they are towards the growth direction. So these are the large secondary branches. Coming up are the small branches, which are the newly evolving technologies. Electricity single generator system and fuel cell has been kicking up in the last window, meaning that in the 2000s, fuel cell has been playing an important role in the green energy sector. And lastly, we have the downgraded gray communities, which are, I can just refer to them as dead branches, because they once evolved over here in the early windows of 1980s, 85, but they never came up as the first or the second rank holders in the US green energy sector. Though once they have been in the third or second position, but their growth was stalled, and they might be evolving, but they never come in the top 3 positions anytime later on, this onwards. So this is my green technology tree. And in the conclusion, what I want to say is that we try to identify the top 3 communities existing from 1980 to 2005 and try to capture the evolution and growth using a tree structure. And we do feel that US green energy sector is predominated by the water, that's the hydro and the wind energy systems, which have proved to be much mature technologies than the other sectors. Fuel cells seems to be kicking up and might be a promising field for the future, but we need more research for that. And of course, we do feel that more effort is needed in the biomass and the geothermal sector so that they can compete with the peers. I mean, they can compete with the wind, solar, and the water energy. And that's it. Well, thank you.